Okay, so first we have a couple of definitions. And the second one covers all cases. The first one is if you have a rational. So rational is that word that means fraction. So we have fractional exponents. If you have a fractional exponent and the numerator is 1, whatever the denominator is just becomes the index of a radical. That's how those two things are related. If we have a numerator other than 1, we have to not only put it under a radical, but we also have to raise our answer to a power. So whenever you have a fractional exponent, it's representing some sort of a radical. So you see a fraction and exponent, it's the same as a radical. So what we're going to do first is we're going to use radical notation to write each expression and then simplify it. So there are 2 steps to this. Your calculator will simplify that all at once, but what this section, what I'm looking for, is that you first write it with radical notation, not that you just simplify it. So when you're looking at one of these problems, the big number is your base. So you take your base and keep the numerator to be an exponent. The denominator of that rational exponent is the same as the index of a radical. And recall that index is that little number. So this is the same as 2 for an index on our root, and then 25 to the first power. Well, what's 25 to the first power? 25. So this is looking for, what does an index of 2 tell me? What kind of root? Square root. So to simplify, so that's the first step. It's writing it in radical notation. Second step is to simplify. What's the square root of 25? 5. And we're looking for that positive square root because there's no negative in this problem. Yeah. Yes. Yes. We're going to get to some of those down here to see what you do when it's other than 1. Because you have a couple options, actually. So now when you write your answer on your drill, on your test, the only thing you have to write in your answer is 5, but I will be checking your work to make sure that somewhere in there I see that you have the radical form. Brittany. The 2 just tells us what kind of root we're taking. So the little 2 is the index here. It just tells us that it's a square root as opposed to like a cube root or a 4th root. So for B, I have 27 to the 1/3 power. So the 1 stays on the 27, and the 3 tells me what type of radical I'm going to have. That's the index number. So when I go to write my radical in the index this time, I have the little 3. And then underneath, we have the 27, and it's to the first power. But again, 27 to the first power is still 27. So you don't even really have to write the first power if your numerator is 1. So it's always going to be the same radicand. And what's the cube root of 27? 3. Because 3 times 3 times 3 is 27. That's what the index tells us, is how many times you'd multiply the answer by itself to get your radicand. Now in C, we've got a lot of stuff going on. And this is going to be the first example of parentheses here make a world of difference. Parentheses, holding in that whole term there, say everything gets to go under the radical. So because there are parentheses, everything is included. And my index is from the denominator, which is 3. So I'm looking at a cube root of the whole thing, negative 8x to the 12th, y to the 6th, and that was all raised to the first power. Raising things to the first power doesn't change them, so we're looking at the cube root of negative 8 x to the 12th, y to the 6th. Okay, take the cube root of a negative number and get a real answer. Yes. If your index is odd, negatives underneath still produce real answers. And remember, if you're not sure, type it in your calculator. If it gives you back an answer, you're good. If it gives you an error, it's not real. So it's the cube root of -8. -2. How about the cube root of x to the 12th? How do we deal with those variables? Divide. For variables, it's division. You're just going to divide the exponent by your index. So we're going to get x to the 4th power, and then y, we take 6 and divide it by 3. We get y squared. So numbers are from your calculators, or when we get to 10.3, we'll learn how to simplify them when they're not from our calculator. And variables, we're always just concerned with division, dividing our exponent by our index. So D, we have a 1/2 power. A 1/2 power gives us what type of radical? Square root. So a 1/2 power is always a square root. And you'll see that that concept is going to travel through calculus if you get that far. So the fact that a 1/2 power always lines up with a square root is a very common math concept. My question, what's going underneath the square root? I have a vote for 7x. Anyone agree? 7x? Got a couple people agreeing? 7x? Now, how did we get everything underneath the cube root in C? Parentheses. What don't I have in D? Parentheses. So if I don't have parentheses, that exponent, so let's just as an aside, if I have the term 5x squared, what's the squared with? The x, just the x, right? The 5 is 5. If I squared it, I get 25. That's not the term. It's 5x squared. So we see that the exponent is only with the x. So here when we have a rational exponent and there's no parentheses, the exponent only applies to what it's directly on, what base it's on. Because there's no parentheses saying take all of it. So this problem really, if you were to visualize it a little bit more, is 7 times x to the 1/2. The 7's not connected to the x. There's no parentheses holding those two together. So the only factor of this that has the exponent that has the 1/2 power then is the x. The 7 is just a coefficient. Now if I put it in parentheses, 7x, and raise it to the 1/2, then the 7x would go under the square root. But because there are no parentheses, the only thing that has that rational exponent is the x. The 7's just out front. 7 times the square root of x to the first. Now a simplified way of writing that would be 7 times the square root of x. When you have a square root, if your index is 2, you don't necessarily have to write it. It's implied. And raising x to the first power still gives you x. Yana. Nope. It's not associated with that rational exponent. Now again, if I put parentheses around the 7x, then you throw the whole thing underneath. And we can't simplify the square root of x because its exponent, 1, is less than its index. So up to this point, if we're going to simplify, everything has to be evenly divisible. And then Monday we'll learn what happens when it's not. But if your exponent is less than your index on variables, you can't simplify them. Less. Questions? So parentheses make all the difference here. So if you look at E and F, they are almost exactly the same problem. The only thing that's different, one set of parentheses. So question, which one of these or both do you think is the square root of -25? Which one's going to get the -25 underneath the radical? your F, or both. I have a vote for F. Both of them. Both of them. No. How do we get everything underneath the radical? What I say it has to have around it? Parentheses. As picky as a negative sign. So think back to 10.1. I know it was a while ago because of our test. But in 10.1, one of the first things we talked about was this idea of a principal and negative root. That sometimes I want the principal root, sometimes I want the negative root. Well, if I'm using rational exponents, there still has to be a way for me to tell you principal or negative root. And I said before, if I want the negative root, I'm just going to slap a negative sign out front. So the same thing applies here. If your problem has a negative sign, just kind of sitting in front of it without parentheses, this is really just, we'd read this as the negative of 25 to the 1/2 power. That's just asking for the negative root as opposed to the principal root. Versus F, which says take the whole quantity, the number negative 25, and that's going underneath your radical. So parentheses will tell you as much as take the negative sign or don't. If you don't have parentheses, the negative sign is out front, and it's going to be the square root of 25 to the 1st power. This is the negative root instead of the principal root. And the way I indicate that is still just slap a negative sign out front. Versus, and we'll simplify that in a second, versus F, which has the parentheses, which tells me the negative sign makes it underneath. Without the parentheses, you can't carry so much as a negative sign with you. So let's look at the different ways these simplify then. This is negative square root of 25. Is that going to be a real answer? Negative on the outside, square root of 25. What did I say, Napoleon? Negative 5, yeah. It's just the square root of 25 is 5. Slap a negative sign out front. Negative 5. It's the negative root. How about the square root of negative 25, where the negative's underneath? That one's not a real number. So they are very, very different problems. And it all comes down to just watching your parentheses. You don't have parentheses, just don't take your negative sign with you. Leave it out front. You have parentheses, bring your negative sign underneath. So you need parentheses if you want that quantity to go underneath a radical. So we have negative 5 versus not a real number. And again, that capital R that starts with the 2 lines is just the math symbol for real number. You can certainly write out the word real numbers. Questions? So in chapter 10, which is unit 3, is just chapter 10, it's not that we have long problems necessarily. It's just that there's lots of little things. So there's lots of little things in chapter 10 versus chapter 7 where everything was just a really long process. So your unit 3 test will have a lot more questions because they're really short, but it also means they're worth less points. Now G is the first example where our numerator isn't 1. And there's 2 different ways you can solve this. There's one way that I'll always do in the problems after this section, but there's 2 different ways that you could, I should say, simplify this. So it's the same setup as before. We're going to keep the numerator with the 9, and the denominator is our index. So we're looking at the square root of 9 to the 3rd. Or the other way you can write this is the square root of 9, then raised to the 3rd. So you have a choice whether or not you want to take the square root first, which this is the way I recommend, especially if you don't have a calculator. Or if you want to use a calculator and evaluate the exponent first. So you're going to have to do both. You're going to have to do both the exponent and the radical. Which order is totally up to you. Does not matter. So if you wanted to go the first route, you'd start by evaluating, and you'd use a calculator, 9 to the third power, which I think is 729. Yes? Okay. So we still have the square root because we haven't evaluated that. If we just evaluate 9 to the third, we get 729 under our square root. And then you take your calculator and you look for the square root of 729, which should be 27. So it would be 2 steps, both of which you'd probably want a calculator to do. But the second way you could conceivably do without having a calculator handy. So the second way says, instead of starting with the exponent, start with the square root. So what's the square root of 9? 3. Again, something you could probably do without a calculator. So this time we're starting with the square root, and then we're doing the exponent second. And what's 3 to the third power? 27. I think that way's a little bit easier because your numbers aren't going to kind of blow up. But either way is acceptable. They are both mathematically correct. You see, you get the same final answer either way. So you have to do both. Make sure you do both the radical and the exponent. The order in which you apply them does not matter. So for H, my first question, so we've got a few things to think about here. Where does the negative sign go in H? Does it stay out front, or does it go underneath the radical? It stays out. No parentheses means it doesn't have a pass to come underneath. This is just the negative of 256 to the 3/4 power. So the negative's going to stay out front because I don't have parentheses. So I'm just going to put my negative down. Not include it in my little circling. And you don't have to circle, it's just the way I remember what to do. So we're looking at the negative of the 4th root of 256 to the 3rd power, or, and you don't write both of these, you just one or the other, whichever you prefer, negative 4th root of 256 and then to the 3rd power. So it's up to you which way you evaluate that. So if you go the first way, I'm going to need a calculator for this one. And this is why I don't necessarily recommend the first way. So if you start by evaluating the 256 to the 3rd power, we're looking at the 4th root of 167777216. So you're looking at the 4th root of that number. Let me tell you, you're more likely to make an error if you go to try to type that back in. So if we take the 4th root of that, we get 64, and then again, I'm just bringing that negative sign down. Negative sign is just coming down in the front of each line. So I get the answer negative 64. Versus the other way. The other way says take the 4th root first. Negative sign's out front. So if I take the 4th root first, I get 4, so it makes the number smaller and more manageable instead of bigger. And then I raise 4 to the 3rd power, I get 64, and I bring down my negative sign. So one way your numbers get bigger, one way your numbers get smaller. They both work out to the same final answer. Questions? So we just went from rational exponents to radical notation, which means that it's got to be possible for us to go from radical notation back to rational exponents. So that's what we're going to do next. So you're given the radical, and your problem is to rewrite each expression with rational exponents. So when I have a rational exponent, there's a fraction. So I need to have a number for the numerator and a number for the denominator. I need one number for the numerator, one number for the denominator. Which number always gave me the denominator? Which number on my problem, what part of the radical is always associated with my denominator? Do you remember what that's called? The little number. What's that? The index. The index is always the denominator. So when I'm looking at a square root, what's my index? 2. So let's start by putting some more numbers on this thing, because we need some more information. So the index is 2, which we know goes on to be the denominator. What do you think the numerator is going to be? 1. So if there's not a power on your radicand, we could always say that 11 is the same as 11 to the first power. So if we go backwards, we take our 11, we keep our first power, and then we take the 2 from the index. So this number here, it's still from the index. If you don't have an exponent on your problem, you can always put a 1. And I said before, I think I said the cube root. No, it was the square root. 1/2 power always represents the square root. Always. Straight square root, 1/2 power. So for B, what do you think the rational exponent is going to be? I need both a numerator and a denominator. 1 is the numerator, since there's no exponent. What's the denominator? 3. Now, how am I going to make sure that if you were to go backwards with this problem, that both the 7 and the x come underneath? What am I going to need? Parentheses. Parentheses is the only way that whole quantity gets underneath your radical. So I need parentheses to say, take everything. If you were going underneath the radical, it doesn't have an exponent, so we put a 1. And then the number that's the denominator, just like on the front, is the index. And then for C, I'm going to have x to what power? X to the 4/5. So this time I have an exponent that applies to my entire radicand. So I'm going to take the x to the 4th. I don't need to put the 1 on because it's got a 4. And then the denominator is always the index. So I have x to the 4/5 power. Try D. D is always interesting. You're going to get a bunch of different answers for D. So I want you to write down what you think the answer for D is. What you think the answer is going to be for D. Do you have a question, Sarah? Around the 7x? For C? Why did I or did I not? Why didn't I? Because there's only one factor, just the x, in the radicand. So if I have more than one factor underneath, then I need the parentheses to say make sure you take the whole thing. But because there's only one, I know that it's going underneath. All right, I'm going to list them in blue. Possible answers. What do we think? 2? Just like the number 2? Y to the 2? Okay, so there's one answer. I told you we're going to get a lot of different answers for this one. I guarantee it. Who's got a different answer? Okay. Kevin, what do you have? I like that? Okay. Anybody get anything different? Devin, what do you got? Anybody get anything different? The only one of those that's actually mathematically correct is the last one. But that's still not how I'd write it, because that would show that I would need 2 separate radicals instead of just one. But I would accept that. And it's very interesting that, Napoleon, you were thinking exactly the same way of just looking at each one of them separately. Your only problem is that your y, you need to flip that around. It would be 2 over 4. So what happened here for the people, and this is the one I think most of you probably have, or you might have 1/2 power, because you said, oh, I could reduce that. The problem with this, when I look at xy squared, which of those variables is squared? The y. When you pull that squared out of the parentheses, you're now telling me that the x is also squared, which it's not. It's just the y. So we can't put the parentheses and then chuck the exponent outside, because then it applies to all of those variables, not just the y. So it's a lot easier than you're making it, I'll tell you that. What do we want to be in the radicand? What do we want? What's in the radicand? Xy squared. So I want that in the radicand, so I'm going to put it in parentheses. So the next person to see this problem says, take the whole thing. What power is on the outside if there's not one explicitly written? 1. And what's the index? And you're done. So raising it to the first power says I have xy squared. So if I raise it to any other power, it's going to start messing with the exponents on the inside. So if there's no exponent written, just like with an 11, just like with a 7x, I have a 1. What throws people off is that the y also has an exponent, but it literally is just like b. You just put parentheses around your radicand, slap a 1 outside, index is your denominator. So that one's always fun to see what people come up with. And it's very interesting that a couple of you said, well, I'm just going to deal with them separately. I'm not going to worry about this mess. So, questions? This way we do not use nearly as often as the other way. All right, so our last topic then, which is still just going on the same idea, is we're now just going to make the rational exponents have a negative sign. And this actually goes back to a topic from the previous class, from 082 or whatever your algebra before this was. And, bless you. The only thing that negative exponents do is they mean we end up with a fraction. So if you have, for example, x to the negative second power, you make that 1 over x to the positive second power. It's, bless you. It's one of your rules. There's 7 rules for exponents, which on Wednesday we're actually going to go back and review all of those. But whenever you have a negative exponent, if it was in the numerator, and we can think about it as a numerator since there's no denominator, we just send it to the denominator. Vice versa, if it started in the denominator and it had a negative exponent, we would just send it back to the numerator. So I always think about it as a switch. You just switch where it is in a fraction. Ayana.
Okay, so by you switching the multiplication to a division, you take away the negative sign.
It's not multiplication to division, it's really switching where it is in a fraction. So if you think about it, and I hate to put it over 1, let me do this. Let me create a different example, because I think that'll confuse you if I do it on that one. So let's say I had let's go with 2, let's try pen, 2x to the negative 5th over 3. So what has the negative exponent with it? The x, just the x. So there's no parentheses, kind of like we were talking about before. So to make this negative exponent positive, right now that x to the negative 5th is in the numerator. To make it positive, I just switch it down to the denominator. So all I'm doing is taking whatever has a negative exponent and I'm moving it down. Everything else around it stays the same, but the concept is that it's switching places in a fraction. But for our problems, it's just going to be one factor here. So you just move the whole thing down. And when you move the whole thing down, you leave the 1. So you'll see in bold, underlined, never evaluate a number with a negative exponent. This is a test question in 082. 3 to the negative 1/2. I get a lot of negative 9s. If you put that in your calculator, you do not get negative 9. You get like 0.11111, I think, something like that. Whenever you have a negative exponent, start by making it positive. So if I have 3 to the negative 2, how do I make that positive? Just do 1 over 3 to the positive 2. I moved it to the denominator. And then I evaluate the exponent. So we're looking at 1/9. So if you put 3 to the negative 2 in your calculator, you're going to get a decimal. It's the decimal value of 1/9. You always make that positive first, and then you evaluate it. So if you look at these problems here, the directions say write with positive exponents. So if you read the directions, it'll give you a good tip-off of where you should start this problem. Write with positive exponents, simplify if possible. So if I have 27 to the negative 2/3, how do I make it have a positive exponent? 1 over. So just go 1 over 27, and now it's the positive 2/3. That's all you have to do to make a negative exponent positive. You get partial credit on a test if you can do that part. It's part of the problem. Write with positive exponents. And then the second part is simplify if possible. So now we're going to go back to what we did on the front. 27 squared. I have an index of 3. The only difference is I'm carrying it all under a 1. And I'm going to go with that second way just because it's a little bit easier. I'm going to work with the radical first and then the exponent. So the cube root of 27 is 3, and then what do I have to do with that 3? Square it. So I'm looking at 1/9. And just don't forget that the 1's there every step of the way. Sometimes I get things like 1 over 27 to the 2/3 equals 3 squared equals 1/9. You got to have that 1 over kind of all the way through. So we're looking at 1/9. So for B, question, is the radicand going to be negative? Does the negative sign for B, before I look at anything else, does the negative sign go underneath the radical or no?
Yes.
Why yes? Parentheses. Parentheses says the negative travels underneath the radical. Now first thing we've got to deal with in the directions is this negative exponent. And how do I make the negative exponent positive? Let's do 1 over. Now the only sign that changes is the sign of the exponent. The negative 27 is still negative 27. The only thing that changes is the sign of the exponent. So there's my first step. That's right with a positive exponent. Now we want to simplify it. So I'm going to have 1 over, my index is 3, so I have a cube root of negative 27 to the first. But you don't even have to write the first powers. They don't change anything. So it's just 1 over the cube root of negative 27, which is 1 over negative 3. Or in the back of your book, they're probably going to put the negative sign right out front, which is fine. I'm okay if you leave it with the 3, kind of where you see it. questions? All right, for C, is that negative sign going to be traveling as part of our radicand? Is the negative sign going to be part of our radicand here? No. Why not? No parentheses. So the negative sign's just going to kind of hang out. And then how do I make that negative exponent positive? 1 over. So 1, the negative can hang out with the 1. It doesn't have to travel. Oops. And then it's going to be 256 to the 3/4. I don't take the negative with me because there's no parentheses. Negatives only stay with the number if there's parentheses. And then this is actually one that we evaluated on the front. So I have negative 1 over the 4th root, it's my index, of 256 to the 3rd, which is negative 1 over 4 to the 3rd, it's negative 1 over 64. Again, once I move it to the denominator, the process is all the same as the front. Just make sure you keep the 1 in each step of that. Sometimes I get this in the beginning, and then I get the answer is the 64 without the 1. Sarah? It's not wrong because technically they're equivalent. If you move the negative to the denominator, as long as you didn't put it underneath the radicand, you're okay still. Same question, Devin? Yeah. Because mathematically they are equivalent if the negatives in the numerator, denominator, or out front. As long as you don't put it underneath the 4th root, you'd be okay. And then last D, 64 to the negative 2/3 power. When you see a negative exponent, that's the only time you do the 1 over. Just because you see a negative in your problem doesn't mean it's 1 over. It's only if the negative is part of the exponent. So I see the negative in my exponent. I know I need to make that positive by doing my 1 over. And now I'm going back to the front and just rewriting that denominator so I can simplify it. So I have an index of 3, so a cube root of 64. And then I'm going to take that answer and square it. So I have 1 over 4 squared, which gives me 1/16. And you could, again, square 64 first and then take the cube root. You're still going to get 16. Still get the 16 there.